All right, so let's get into one of the most ambiguous concepts in Elasticsearch, which is sharding. So, an introduction to sharding is that sharding is a way to divide indices into smaller pieces. So, let's uh, keep keep on going into the intro, and then I will create some examples and some images to uh, make it simpler. Okay, so the next thing is that each piece is referred to as a shard. So we divide indices into smaller pieces, which named shards. Okay, that's easy. And the sharding is actually done at the index level. What it means actually is that each and every time that we create an index, as we are going to see, as we have seen before, the Elasticsearch itself is going to create the shard, one shard for that matter, for that index. So it's not something that we manually do whenever we create an index. So that's something new. And the main purpose actually is to horizontally scale the data volume, which we are going to see how it's done. So let's say you have two nodes, each with 500 gigabytes capacity, but you have an index with, I don't know, 1 billion documents in it that is 600 gigabytes. So you cannot fit this index into either of these nodes. So what you should do is to create a shard, two shards for that matter. Each can be, for instance, 300 gigabytes, or it doesn't have to be equal in the size matter. So it can be 400 gigabytes and this can be 200 gigabytes, and then you can put your docs into these two shards. So you may have been wondering that what shards does to our index or to our docs. It actually does nothing to it. So the shard is a virtual place to put your documents in it. So it's not something odd or weird. So you don't have to be worried about that. Okay, if you want to get a little bit more deeper, we have to say that a shard is an independent index. So you don't know, you may already know, or if you don't, actually Elasticsearch is built upon Apache Lucene. So each shard is an Apache Lucene itself, Apache Lucene index itself. And Elasticsearch index consists of one or more Lucene index. So it's actually too close in terms of index. So you can sort of consider a shard as an index in Elasticsearch. And about the shard size, so a misconception is that, as I actually mentioned myself here, a shard actually doesn't have any predefined size. It grows as documents added to it. So as we created these two hypothetical shards, we put docs in it so that it does get into the size of 400 gigabytes, for instance, or 300 gigabytes. Doesn't matter. So it's very important, and it is some kind of interview question, that does the shard have any predefined size? Its answer is no, it doesn't. And a shard can store up to 2 billion docs in it. So one criteria to know when to stop putting your docs into the shard is that the shard can take up to 2 billion at its most. Okay, so the purpose of sharding is actually to be able to store more documents into the indices and to fit larger indices onto nodes. So actually we are organizing our indices, our docs. Let me say, maybe say it like this, and it actually improves the performance by query parallelization. What it is, the query parallelization, we are getting into it later on in the course, but simply put it, we can actually put any document simultaneously into both of these shards. You may ask, it's data duplication, right? But it doesn't apply in Elasticsearch. Data duplication doesn't sometimes apply in Elasticsearch, because in Elasticsearch we care more about preventing data loss. So that's why you can put your, for instance, first doc here and simultaneously in here, and when you query that to get that specific documentation, you parallelize the query. So if this node by any means is faster than this node, we're going to get the result from this shard B faster than this one. So query parallelization is something like that. And about configuring the number of shards, so an index by default contains a single shard, but before Elastic version 7, each index were created with 5 shards, which led to oversharding, some concept that leads to maybe data fragmentation or something like that. So you can actually increase and decrease the number of shards by 2 APIs named split and shrink. Okay, so the next question that may occurs to you, the next couple of questions, is that how many shards do I have to create for each of my indices? So the answer is that there is no actual formula to yield a number for us. So there are some factors involved, so it really depends on something like the queries you want to do on that shard, the number of the docs, the capacity, the size of that documents that you are putting into that shard, and etc. So if you can, you have the option of anticipating how many millions of docs you want to put in the shard in near future, right? So you may create an index named product, for instance, right? And you anticipate that your products will never ever take up more than, for instance, 1 million number, 1 million products, right? So in that case, you always stick to this default setting. So that's one thing that you should remember. But if you consider, I don't know, 200 million, 1 billion, or even more, you can create more shards, so you'll be comfortable in the near future. All right, so because it was a long lecture and maybe a complicated one, let's sum this up. So first of all, sharding splits our indices into smaller pieces. That's what it does. Sharding actually increases the number of documents an index can store, because each index can have multiple shards in it. So that's one option for us. And sharding makes it easier to fit large indices onto nodes, because we have more shards in one node instead of having one shard or having one node, having one index, I'm sorry. And sharding actually will improve our query throughput. An index defaults to having one shard at the index level, so whenever we create an index, the shard will be created with it. And what else? Yeah, you can add a couple of shards for large indices only, otherwise use default setting. So let's have one more thing. As I promised, we can actually see our shards here. So let's get cat indices. Okay, so I actually removed our own index. So we have the Kibana e-commerce index only, but you don't have to. So here, if you take a look, let me do this. Yeah, so there is something named PRI that implicates the primary. The primary actually is the primary shard. So our index does have one shard. That makes sense because we said so. And we are going to talk about replicas in the future, but just so you know, the rep represents the replicas. So we are not going into talk about it in this course because it's already too much, but you should know that the pri or rep is for our sharding. So if you in the index level, when you create the index, you maybe put 5 shards for this index, you get 5 primary shards. That easy. Alright, so I hope you enjoyed this course, and in the next one we are getting into shards more.